Hey guys, I wanted to come back to some converting form stuff. That's why it's called Lesson 4, Converting Forms Revisited. Specifically this problem, which I didn't ask you to do before. What we did on Friday, if you remember the quiz, was that we did standard form to factored form. And we were using our tables to figure out how to get from ax squared plus bx plus c to factored form. But I want us to be able to go from vertex form to factored form also. And we can do that. One of the things we could do is just multiply it out and go to standard form, since we know we can factor from standard form. So if we did multiply this out, we'd have to start with the x plus 1, right? Multiply all that out. So then we'd have x squared plus 2x plus 1 that we'd be plugging in. And then we distribute the 2 to all those terms. Then we've got our like terms at the end, that positive 2 and negative 8. That'd be our negative 6. And then we'd be ready to factor. So we've gone from vertex form to standard form. And now we know we can factor from this form. If you notice, all of them have a 2, or divisible by 2. So we can take a 2 out to make factoring a little bit easier. And then we're ready for our table. Our table would be about x squared and 3. And since it's a negative, it would be a difference table, right? Our only possibilities for x squared are x and x. Our only possibilities for 3 are 1 and 3, which is good because when we link those together, 1x and 3x do have a difference of 2x, which is what we wanted. So we know we can factor that. And so I put in the x and the 3 and the x and the 1. I chose for 3 to be positive and 1 to be negative because I knew I wanted a positive 2 out of this. So I needed a positive 3x and a negative 1x, right? So it's definitely possible to go from vertex form down to factored form. We just have to stop at standard form along the way, which is fine. That's doable. But I wanted to talk about, is there a faster way to go from vertex form to factored form? And of course there is, or we wouldn't have this video, right? So I want you to think about, just for a minute, pause and think back a couple lessons ago when I made you graph these guys in factored form. Remember, factored form is the only form where we don't start with the vertex. Instead, we started with the x-intercepts. Remember, x-intercepts happen when y is 0. That's when x-intercepts happen. And we were thinking about, okay, what would make each of these sets of parentheses 0 so that when I plugged in, I would get 0 out. And if you remember, we said that we would get x-intercepts at negative 3 because that causes this to be 0, and positive 1 because that causes the second parentheses to be 0. So here's a thought. If we could figure out from vertex form, if we could figure out the intercepts, so go straight from here. Let's turn this guy. Turn him and flip him. Oy vey. There we go. Oh no. I give up. I'll just draw it. If we could go from vertex form straight down to intercepts, then we could go from intercepts right back up here. We should be able to, at least, right? Once we know the intercepts, we should be able to plug kind of back into what factored form would have looked like. So that's what we're going to talk about. How do we get intercepts straight from here? Well, same ideas. We get intercepts when y is 0. So we'll do the same thing in vertex form. We'll say y is 0. If you remember back from Algebra 1, we solved a bunch of these, and we did that by getting the parentheses by itself first. So we add the 8 over, then the 2's being multiplied by the parentheses, so we divide it over, so 8 divided by 2 is 4. And then now that the parentheses are by themselves, we can square root to get rid of the square. And if you square root both sides, that'll cancel out the square over here, so we should just have x plus 1. And the square root of 4, hopefully you remember that the square root of 4 is not just 2, When you square root, you always do plus minus. So the square root of 4 is positive 2 and negative 2. And then we just have one step left to solve. Now, a lot of people in Algebra 1, when you were back in Algebra 1, you would have left it looking like this and then subtracted the 1 over and thought that your answers were plus minus 1, which is not true. We know one of the answers is 1, but the other one's negative 3. So that's not what we're supposed to be getting. I would totally recommend that you take this plus minus 2 and you split it apart into two separate equations to make sure you get two separate answers. So I've split it apart and said that x plus 1 was equal to positive 2, and separately x plus 1 is equal to negative 2. Now when we subtract the 1, we're going to get 1 out of this first guy, but when you subtract the 1 from negative 2, you get negative 3, and there are our intercepts. So yes, it's definitely possible to get from vertex form to intercepts, which we can then put back into our parentheses. If our intercept is negative, we know it was positive in the parentheses. If the intercept was positive, we know it was negative in the parentheses, right? So that should be fairly easy to do. Let's try a couple more. All right, so I want us to go to factored form, and I don't want us to have to multiply all this out to get to standard form and then to do factoring, because that'll just take too long. So let's see if we can get straight to the intercepts so that we can go to factored form immediately. So to get to the intercepts, we know we have to plug in 0 for y and then solve. So the 54 has to go first, subtract it across, so negative 54. Then the negative 6 is being multiplied, so divided over. Negative divided by negative is positive, and that's a 9. Square root both sides to get rid of the parentheses squared. And the square root of 9 is plus minus 3, although you know you should separate that immediately so we get both correct and separate answers. Both of those need 7 added to them. If you add 7 to positive 3, we should get 10. If we add 7 to negative 3, we should get 4. Okay, so now's the part where we actually need to put it into factored form. So if it was, oops, that's not what, there we go. If it was positive 10, we know that in this form, in the parentheses, it was minus 10, because positive 10 would make this parentheses equal to 0. Again, positive 4 would have been negative 4 in the parentheses, because positive 4 would make this parentheses 0. And the last step is we just need to plug in our a value. If we look back up here, our a value was negative 6. There we go. Negative 6. There we go. That wasn't so bad, and we didn't have to do all kinds of multiplying out, and we actually didn't have to do any factoring. We just had to find the intercepts and put them back in. Okay, let's try one more. It's kind of a weird one. It's weird because I've never really given you one where it wasn't just an X in that spot. So actually, this changes things a little bit. If I asked you to graph this, you don't read the vertex exactly the same, because that 2 changes things. We'll talk about that here in a minute, but let's still solve it just like normal. Solve it to look for our intercepts, so plug in 0. Then we'll subtract the 64 across. I don't know if you noticed this guy up in the front, there's a negative up there, which remember is really like a negative 1. So we need to divide that negative 1 across to make it a positive 64. Square root both sides to get rid of the parentheses squared. Square root of 64 is plus minus 8, so we'll split that right away. And then solve both of those. So add 1 to both sides, which would cause a 9 over here and a negative 7 over here. And then divide by 2, which would cause this. So, decimals. Does that mean that we should just go ahead and plug those in? If it was a positive 4.5, it would be a negative 4.5. And if it was a negative 3.5, that means in the parentheses it was a positive 3.5. And here's where that tricky part comes in. The a value is actually not just negative 1. Think about if we were to multiply this out. Actually, I've got it here for you. Say we did start to multiply this out. We'd have 2x minus 1 times itself, and that would give us a 4x squared, which we would then multiply by the negative 1, right? And then add 64. So if we put this in standard form, it'd really be a negative 4x squared in the very front. So the a value is truly negative 4. So if I was really going to put that in, I'd have a negative 4 here. I know that's weird, and we can talk more about that on Monday. But take a look at this supposed factored form. If we multiply this out, we'll get the standard form that this would get if we multiplied it out. So they are equivalent. But did we ever factor and have decimals? We never wrote decimals when we were factoring. So this is not really the way I want it to look. So remember our factors are, we use those to find our intercepts, and we see like when is this going to be 0, and that tells us our intercept. Let's use that idea of when is it equal to 0. I want you to stretch your brain a little bit. Come back up to this step. Could I get this guy equal to 0? It'd be pretty simple. I just have to subtract the 8 over, and here I just have to add the 8 over, right? If I subtract the 8 over, I'd have a negative 9, and then I'd have 0. And here, if I add the 8 over, I'd have a 7, and it'd be 0. Let me ask you something. If you solved this, if this guy was, whoops, we'll have to change that. Actually, let me go ahead and change that right now. Let's see if it come up. If this guy was in the parentheses, and I said, what is the x-intercept of this? Wouldn't you set that equal to 0? And if you solved that, you'd subtract the 7 over, and you'd be right at this step, and you'd still get the same intercept. Same thing here. If I said, what causes this to be 0? You'd set it equal to 0 to figure it out. You'd add the 9 over, and you'd be right here, and you'd still get the same answers. So this factored form has the same answers as this factored form. The only thing that we need to think about is that a value that I took out. Think about if you were to distribute this out. Wouldn't the 2x times the 2x already give you that 4x squared? So I don't need a 4 in the front of this. What I need is just a negative 1. Oh, let's go back. Because if I had a negative 1 in front of this, after I multiplied it all out, I'd take that 4x squared times negative 1. Then I'd have that negative 4x squared I know I needed from this. Which actually feels a lot better, because then this a value looks like it matches that a value, right? Okay, so I know this was a weird one, and it happened because we got like weird answers for our intercepts, and we never throw those into parentheses. So we'll do some more of those on Monday also, where you use kind of a different spot to plug in. Okay, you might want to watch this again if that was kind of confusing. But I will see you on Monday, and we'll talk a little bit more about it.